This is pre-cal. I apologize. How are you guys doing? Sorry that I'm not here again today, but show goes on. We still have some work to do. All right, so we are talking today about properties of exponents and logarithms. Hopefully you have a worksheet in front of you that looks like the one that I have up here on the screen. All right, we're going to talk about some things that you should already know, but it's probably been a little while since you've done them. So first off, multiplying bases. You need to know all these properties of exponents. These eventually we're going to get into solving equations, and the more you know these properties, the more the equations will be solvable for you. Okay, so back in Algebra 2, you learned, and really before that, but we use this in Algebra 2, we learned about like bases. So if we want to multiply like bases, and we have some power of m times some power of n, and they both have bases the same of a, we would add these exponents. So this would be an example of like x cubed times x squared. Your answer would be x to the 5th power. You're adding 3 and 2. Okay. In these cases, if you have a power to a power, I always think distribute. You're going to distribute a power times a power because this parentheses right here means to multiply. It's kind of like if you had 2 times x plus 1, you would distribute. Same idea here. This is going to be m times n power. So how this would look in terms of a problem is you would have maybe something like x squared to the 3rd power. This time you multiply. You would get 2 times 3 is 6. Notice we're not adding them, we're multiplying. Again, the way I think about this is power to a power. A power right here next to a number that's another power, and I would just distribute those. In this case, we have 2 bases. We have the a base and we have the b base that are individual. Over here we just had the a base. And this m will again distribute, but it will distribute to each individual base. So this would be a to the m power times b to the m power. Okay, it would be something like this. If you had x squared times y cubed, all squared, we're going to take this power of 2 and distribute it to each one. So that would become x to the 4th because we're multiplying. And over here we're going to distribute, this would become y to the 6th. All right, next one. Anything that's a power of 0, any base to a power of 0 is always the answer of 1. Anything at all. Okay, so that's just a common rule that you need to know. It's called the 0 power. All right, as we scroll down, if we subtract powers, that is when we are dividing. All right, so we might have x to the 5th power over x squared. We would subtract these. This would become x to the 3rd power. The way I like to think about this is this division bar is like a big subtraction sign on my head. Subtract the numerator power from the denominator power. And sometimes when we do this, we get negative exponents, which we're going to talk to you about in just a minute. When I subtract 2 minus 5, this time I get a negative 3 over here. That's also possible. Okay, we'll talk about that in just a second. All right, back here, now I have 2 bases, a and b, just like before. This power will go to the numerator, and the power will distribute to the denominator. So this would be the same thing as a to the m power times b to the m power. So it might be like x squared over y cubed, all, let's say this time to the 4th power. I'm going to distribute here. 2 times 4 is 8. I'm going to distribute here. 3 times 4 is 12. That would work true. And now we're going to kind of come back this negative exponent. And this is what I was talking about right here. This negative exponent can be written certainly a certain way. Okay, we never technically want a negative exponent. We always want positive exponents. First off, if you have something to a negative power, you flip the base. All right, so a to the negative 1 power is the same thing as 1 divided by a. So if you had 2 to the negative 1 power, the answer would be 1/2. Okay, a to a negative n power is 1 over a, just like before, but now the n power becomes a positive number. What I usually do is I think of this little division bar as a magic wand. Anything that crosses over the division bar is going to magically change that power to a negative or to a positive, depending on what it was. Okay, so over here, let's say I had 2 to the negative 3 power. Well, that means it's 1 over 2 to the 3rd power. And if we wanted to go further, 2 to the 3rd power means 2 times 2 times 2 again, which means this answer is 1 over 8. Those are some examples there for you. And sometimes you'll have it the other way. You might have 1 over a to the negative 5 power. Well, that means we're going to take all this base and move it to the top. It would be a to the 5th power. Okay, and all we're doing is taking the exact base, the exact power. All we're doing is changing the sign when everything moves up or down, in this case up. Okay, these are things that obviously we should have some practice from in the past. All right, now we're going to talk about rational exponents. And this is probably a really good one leading into what's called logarithms. You always need to know this is going to be the case. We have what's called a base. In this case, my base is the letter A. The base is always what you're raising to a power. We have a power, and we have what's called a root. So we have base, root, and power. And the way this kind of translates is that the root is this thing. You might have a square root or a fifth root or whatever it might be. This would become my root. And usually you write the root number right in that little top corner. Unless it's a square root, you don't have to worry about that. We have our base, and then we have our power. So in this case, my base is A, my power is 1, my root is n. So this would turn into, if I do it the same way I did before, I'll use the same colors, the nth root of A to the first power, which is just A. So as an example, I might have x to the 2/3 power. If it was x to the 2/3 power, this would be the same thing as the cube root, because that's my root, of x squared. And what I've just done here actually is an example over here. Okay, because we don't have a 1 over a number, we have a different number over a number. So same idea. Let's see if I write this out. Let's see, A is my base. My root is the nth root, and my power is the m power. So it's base power over root. And you can rewrite these. All these different facets are going to help us be able to solve logarithms. Okay. All right. So what we're going to do down here is rewrite all these numbers. Come on in. All right. And you're going to go and try to rewrite all of these in terms of powers. For example, 4 is 2 squared. Write them all out in bases of 2's or other numbers as best you can.